So we have two triangles up here that I told you are similar. And remember what the similar sign is? It's just that little tilde, right? So we have a similarity statement. Bless you. Who can remind us what the three-part definition to similar was? Give me one of the three pieces. They have to have what? Not the same size, the same, Daisy? Same shape, I agree. So I agree they have to be the same shape. There's two more pieces. What else do we remember, Jay? They have to have congruent angles. So all of the corresponding angles are going to be congruent. And then there's one last piece, and that's the part that we spent a lot of time on last time. The sides have to be what? They have the same proportion. Very good. So the sides are going to be, corresponding sides are going to be proportional. Okay? They have the same scale factor. And we'll talk more about that today. Okay? So that's our three-part definition for similar figures. They don't always have to be triangles. We can have different shapes, and we'll look at some of those shapes today. But we do have this statement, and we're going to refer back to it because sometimes the orientation might be different. Let's say that this triangle, for example, on the right might be turned around or sideways. They're not always side by side looking exactly like they should. So we have to really rely on this statement, okay? When we're given that statement, we can write a lot of things, and so that's what we're going to be doing, okay? Let's list three pairs of angles that are congruent. So for example, what is angle A congruent to? According to this, angle A and D correspond, so angle A and angle D are congruent. If they're similar, that has to be true. I can actually mark it on the picture if I wanted to. Okay, good. Give me another pair of angles that would have to be congruent. B would be congruent to what? B would be congruent to E. Very good. So angle B and angle E are going to be congruent. I agree. I can even mark those on the picture. Again, referring to the statement, right? Looking at that similarity statement, the order of the letters is essential. And then what's the last pair of angles that would have to be congruent? C and F. Very good. So angle C and angle F would have to be congruent. I agree. Excellent. Again, we just said this part of our definition, the corresponding angles have to be congruent. So we can say that. That's awesome. Now we're going to look at the proportional sides. Okay? So we're going to be looking at this piece. And we're going to list all of the side measures that are proportional. But we're going to write it as what we call an extended proportion, okay? Which means because I have three different sides of a triangle, we're going to write a proportion that has three. In that quiz trade activity, how many of you had one that looked like this and had X's and Y's in it? Remember that? So you had to treat them two at a time. So we've seen that already. And let's just start. Let's go maybe from the large triangle to the small triangle. Again, just writing the words so we feel comfortable, okay? And I'm going to color code. And if you happen to have three different colors, feel free to do the same as me. I do have some highlighters back here. If you would like some to get three different highlighters, feel free. They're going to be on the back table back here. Feel free to do that. Or you can just write them. It's not a big deal. But let's see I'll tell you what I mean. What does the side AC correspond to in the other triangle? Good. So I'm just going to color code those with the same color. AC and DF. And AC is the large one, and DF is the small one. They correspond to each other. Do you agree? Okay, let's keep going. Let's use a different color. Let's write another pair of corresponding sides. How about AB? What does it correspond to? Martin, get off your phone, please. DE. Okay? So we're going to write those also. Remembering that we have to go in the same order, we're going to have to go from large to small. which is why I think the words are important, because it tells you the order to write them. Okay? So we're going to say AB to DE. Perfect. And then, lastly, what would be the last pair of sides that could be similar, or that correspond, I should say? BC to, very good, BC to EF. Notice that BC and EF are in the similarity statement as well as corresponding. So you can always rely on that as well. So BC and EF. The sides are proportional. We can write them as an extended proportion. Okay? Any questions so far? Again, if I am given that the triangles are similar, I can write all of this stuff to be true. And we can imagine that we're going to use it to be able to find missing sides or find missing angles. And that's what's going to come up soon. Oh, question first. Just using the letters to write the proportion there. If I had numbers at the bottom, let's just kind of you don't have to write this down, but just kind of let's look at it for a minute. Let's say that I had that this was 8, this was 4, and this was, I don't know, 3. I'm just making numbers up. Actually, that wouldn't even be a triangle. The two smaller ones aren't larger than the third. Let's make this a 5. Just making it up, okay? And let's say that this one was a 4, this one was a 2. What would that one have to be? It would have to be 2.5, because they have to have the same scale factor. Do you agree? So in other words, 8 divided by 4, we can write this. 8 divided by 4 has to be the same as 4 divided by 2, which has to be the same as 5 divided by, So what is 8 divided by 4? 2. 8 divided by 4 is 2. 4 divided by 2 is 2. 5 divided by 2.5 is 2. So we know that this would have to be 2.5. They have to have the same scale factor. These numbers, by the way, are the scale factor. So if I ever was asking you for the scale factor from the large to the small, what would you write? You're going to use exactly the numbers I have here, from large to small. You could say 8 to 4. You could say 4 to 2. You could say 5 to 2.5. Or you could reduce all of those. What do they all reduce to? 2 to 1. Would you agree? 2 over 1? So it would be 2 to 1, the scale factor. Just reducing all of these numbers, 8 to 4, 4 to 2, 5 to 2.5. Are we okay with that? Now, here's a question that's going to come up in a few minutes when you have some practice to do on your own. What would the scale factor be from small to large? Yeah. Yes, you're both right. So if I'm going from large to small, and it's 2 to 1, if I'm going to go in the opposite order, wouldn't it be 1 to 2? Right? So the order that you write the scale factor does matter. So and it just is literally from large to small. You just write the numbers in the order that you see them. Okay? All right. We'll practice again in a few minutes. So here's example 2. Not triangles this time. What's the shape? Not guaranteed a trapezoid. It looks like it might be a trapezoid, but we don't know for sure. Definitely a quadrilateral, though. Wouldn't you agree? Definitely a 4-sided figure. Probably a trapezoid, but we're not sure. It's definitely not a pentagon because it doesn't have 5 sides. It has 4. It's 4-sided, so it's going to be a quadrilateral. Notice that I still have my similarity statement. That's important because we're trying to find two questions. It's asking us first for the scale factor, and then it's asking us for the longest side. Yes, that's important information. So where should the 9 go? Between which one? Very good. Because the shortest side on the left-hand side is 6. Do you agree? Isn't that the shortest side on the left-hand quadrilateral? And that is RS. What does RS correspond to over here? LM. So it has to be the shortest side. So we're going to label that with the 9. Okay? Always go back to your similarity statement. Again, they might not be oriented the same way. It might be a little bit difficult to tell which one is the shortest side, but you can by just using your similarity statement. This guy tells us a lot of information. So let's start by talking about scale factor. From the small one to the large one. So from the small to the large. Mo, you want to give it a shot? It is 2 to 3. Very good, 2/3. How'd you get that? Yeah, these two guys correspond, don't they? RS corresponds to LM. So, and they both have numbers attached to them, 6 and 9. So those are the numbers you're going to use. And then, so we're going to start with 6 over 9. And then how'd you get 2 over 3? Sure, you just reduced your fraction. Yeah, divisible by 3. If you're not sure, if you just need some extra to check your answer, math frac on the calculator, right? 6 divided by 9, it is 2 over 3. I agree. If you left it as 6 over 9, it wouldn't be wrong. It should be a U. Thank you. Any questions about scale factor? What would the scale factor be from the large one to the small one? 3 over 2. Very good. Or 9 over 6. Yep. All right. Now let's go ahead and find the longest side of LMNO. That's the question at hand now. The longest side of LMNO. Which side corresponds to it on the other one? Oh, what? UT. Very good. So the green sides, and we can double check here that UT and ON are the longest sides, right, according to the statement. Yes, sir?
On the small one, it says RU is 14.
Yeah, that doesn't really make sense, does it? So that's the wrong one, isn't it? It's not drawn to scale. Would you agree? So that's why it's really important that we use, so 14, it's not drawn to scale. Do you agree? Be careful, the picture's not drawn to scale here. So 14 is the longest one on the small side. So in this case, the longest one would actually be LO, wouldn't it?
Wait, what do you mean by that?
Because according to this picture, it looks like ON might be the longest side, but actually because the picture's not drawn to scale, if we look over here, 14 is actually longer than 12, which means LO is the longest side. Okay, just because that's bigger than, that's okay? Good catch, Shane. Okay? So we have to write a proportion to solve. I'm just going to call this X, and we need to be able to solve it. Question? All right, so hang on one second. Let's everyone else catch up. So we need to write a proportion. You may either use the 6 and the 9 or the 2 and the 3. It doesn't matter which one you want to use. But we're going to write a proportion to solve. And we're going to use the numbers from what I've highlighted in both green and yellow. Let's go from the small to the large. Remember how I want you to write the words, right? And we're going to write a proportion. Emily, put your head up, sweetie. Thank you. So when we're talking about the small one, which number do you want to start with, 6 or 14? 6? Doesn't matter. Sure, 6. And then a large one would be 9. Good. So that's the yellow side. Now we're going to do the green side. So we're going to be the small. We're going to say 14 and then x. Huh? I haven't solved it in my head yet, but I want to make sure the proportion's okay. There's more than one way to write that proportion. I could have said 6 over 14 equals 9 over x. That would have been okay too. When we cross multiply, you get 6x equals, what's 9 times 14? What is it? 126. And then we're going to divide by 6. And Kiana, what'd you get? Kiana, what'd you get? 21. That's right, 21. So we can use that, right? We can find missing sides if we're told that they're similar, right? So if we have this similarity statement, we can find the measure of sides. In a minute, we're going to find the measure of angles. I don't want you to write the next example down, because there is one more I want you to write down. But I just want you to look at this one, okay? Oh, that's not the one I wanted to do. I want to do this one, okay? Are the figures similar? Yes or no?
No.
This is the one I wanted you to write down, because I'm sorry. This is the one I didn't want you to. So stop for a second. Let's do this one first, then we'll get to the angle one where you have to write down. We're given a similarity statement here. How would I solve for x? We got to write a proportion. So don't write this one down. Just tell me the order that they go. So I'm going to look on this side for a second, because the side's been awful quiet, right? So what would the ratio be? Remember, we had to think about the corresponding sides. What does AC correspond to? AC corresponds to DF. Do you agree? So x plus 1 over 5. Is that okay? Because they correspond to each other, right? If I wanted to highlight them, so I know that, those correspond. Do you agree? Now I can write what over what? Where does the 6 go? On the left-hand side or on the right-hand side? Because we still have 6 and 12, do you agree? Where do those numbers go? Where they go is important. 6 is on the same side as x plus 1, so it goes over here. And then 12 goes here. Do you agree? Any questions? Could you solve that? We could solve that, right? So we have equals 30. What do I do with that x plus 1? Put it in parentheses so I can distribute it, right? So 12x plus 12 is equal to 30. Subtract 12. You get the idea. This is what we were doing before class started. Or, sorry, the beginning of class, not before it started. Is this right? 18? And then divided by 12. Ooh, what is x? 1.5. Can you get a decimal? Is that okay? Sure. All right, here's our last example, example 3. This is an important one because what your practice that you're going to work on today, you're going to have to answer this question. So make sure you copy this last example, okay? Example 3. Are the figures similar, yes or no? Bless you. Bless you again. Remember at the beginning of our notes, we had a 3-part definition to are they similar. The first one, bless you again, this tissue's back there if you need it. First part was they had to have the same shape. Do these two figures have the same shape? Yeah, they're both triangles. So that's the first start. Okay? So we're going to go through our 3-part definition. So we have one, same shape. And we're going to say, yes, they're triangles. 2, what was the second part of our definition? They all had to have corresponding angles were the same, right? So we had to say that the angles were congruent. I see 60 and 90 on one triangle, and I see 30 and 60 on another. Are they all the same? How'd you get that? How do you know? An eye? Because all the angles in a triangle add up to be perfect. So we can find the missing angle, can't we? Find the missing angle on the left for me, Tony. What's angle T?
Where?
Angle T. How do I find it? We have 90, 60, and what? You have a calculator. They all add up to 180. And then I would like for Sibelius to find angle K. Tell me, we know 30 and 60. Let's find the missing angle. Which one's 30? The T. So T is 30 degrees. I agree. They all add up to 180. Good. Sibelius, what's the measure of angle K? 60 and 30. So 90. Yeah, the missing angle would be 90. I agree. Are all the corresponding angles congruent?
Yeah.
Yes. So far we have the same. They're all triangles. Corresponding angles are congruent. Here's the part that takes a little bit of work, but it's not bad. We need to find the sides have to be what? Proportional. So this is what we need to check. Are the sides proportional? So we're going to write a big extended proportion. This time we're going to put numbers in it rather than letters so we can check to make sure they have the same ratio. Put your hand down for just 1 second. And everyone to be able to catch up. Are the sides proportional? So what you're going to do is you're going to put the smallest corresponding sides over each other, the middle ones over each other, and then the large ones over each other. Not really. I'll show you what I mean. We're going to do large to large. We're going to do medium to medium. And we're going to do small to small. Oops, I did that backwards. Small, oops, 6 is the smallest, isn't it? Small to small, medium to medium. Double check. Isn't the yellow one the largest on both triangles? It doesn't matter. Whichever one you want to start with. That's okay. I just mean the largest in its own figure. I just mean that 5 is the largest in that triangle. And that 10 is the largest in that triangle. That's all I mean. They should. And that's what means that means the sides are proportional. Okay? So let's try it. So let's start with the blue ones. Okay? So when I start with the blue ones, I have 3 over 6. Did anyone do 6 over 3? Is that okay? Doesn't matter, right? If you're looking at scale factor, if I said from small to large, then you would have to do 6 over 3. Wouldn't you agree? From the little triangle to the big triangle? Let's keep going. 4 over 8, and then it would be 5 over 10. And Kiana, since I didn't specify, it's okay if you wrote the fraction out in the other direction. Okay? That's totally fine. So that as long as you're consistent, is 3 over, let's reduce them. You have a calculator. What's 3 divided by 6? 0.5. What's 4 divided by 8? 0.5. What's 5 divided by 10? Are the sides proportional? Yes. The last piece is to write the similarity statement. Triangle blank is similar to triangle blank. So let's do it. Triangle SUT. And this is the part that you have to write. What does S correspond to in the other triangle? No, it does not. S is the 60-degree angle, right? What's the 60-degree angle over there? Good. So M what? What comes next?
Okay.
So U is next. U is the 90. What's the 90 over there? So MKL. Okay? The order that you write that is important. Use the angle measures. That'll help you. Okay? All right, let's get some practice